5.2 Energy and Conservation of Energy. For learning outcome 5.2b, apply the principle of conservation of energy, mechanical energy and heat energy due to friction. Okay, exercise 3, question number 1. An object which is 5 meter above the ground is released from rest. Okay, 5 meter above the ground, released from rest. Determine the speed, okay, v, of the object when it is 3 meter above the ground. Okay, can you imagine this situation? Okay, let me illustrate. Okay, this one. Okay, let's say this is the ground level. This is ground level. Okay, and then this is the object. Initially 5 meter from the ground. Okay, 5 meter from ground. Height initial 5 meter from ground, and then it is released from rest. Okay, so someone must hold that object first, and then it release the object. So the object fall, okay, downward, and then the question asks you the speed when is the object 3 meter. Okay, 3 meter. Height final 3 meter above the ground. Okay, so this is initial position, and then this is the final position in this situation. Okay, well, actually this object will go until it reaches the ground, but we want to find the velocity when it is at 3 meter above the ground. So we may apply principle of conservation of energy. So principle of conservation of energy state that total energy is constant. That means total energy initial equals total energy final. Okay, so you have to identify what kind of energy at initial position and what kind of energy at final position. So initially, this object is at particular height, 5 meter. So that means this object have potential energy. Okay, potential energy initial, and then it is at rest because it is from rest. It is at rest. That means it has no kinetic energy. Okay, you may write kinetic energy initial, but then you can substitute kinetic energy is 0. Or maybe you don't have to write Ki, okay, kinetic energy initial. Okay, and then at final position, okay, at final position, this object still moving, okay, still moving. So it has kinetic energy at final position, okay, final. And then the object is still from particular height, okay, from a particular height above the ground. So it has potential energy U final, okay, at that position. Okay, potential energy at that position, okay. We may say that it is at final position in this case. Okay, then you can write down the formula for potential energy is mg times height initial, and then kinetic energy initial is 0. Okay, because initially it is at rest, it doesn't move. So when the object doesn't move, that means it has no kinetic energy. And then U final, formula for U final is mg times hf, height final, and then K final. Okay, so you have to write down the formula of kinetic energy, which is half mv squared. Okay, so we can factorize m. Okay, we can factorize m. This one become mghI, and then we can factorize m mghf plus half v squared, and then we can cancel the m. Okay, we can cancel m. That's why in this question mass m is not given. Okay, because we can cancel the m. Okay, then we can substitute the value, all the values. Okay, we can substitute all the values. G is 9.81. Height initial is 5 meter above the ground. G 9.81. Height final is 3 meter above the ground, half, and then V is the unknown that you have to find. Okay, so we can determine V. Okay, the speed at 3 meter above the ground. Okay, minus in bracket square root answer. So it is equals to 6.26 meter per second. Okay. Number 2. Refer to figure above. Determine the speed of the object when it reach point A and point B. Okay. So you have to determine the speed at point A, okay, at this point, and then speed at point B, at this point. Okay, so for point A, V at point A, question A, okay, we have to find V at point A. Maybe we can write down the symbol VA. Okay. Okay, so for this one, we can apply conservation of energy. Okay, total energy initial equals total energy final. Okay, let's say this is the initial position, and then point A is the final position. Okay. So we want to find V at point A. So point A will be the final position. Okay. So you have to identify, first you have to identify what kind of energy at initial position. Okay. At this position. So at this position, okay, this object is at particular height from ground. So it has potential energy U. Okay, U initial. And then it is moving. Okay, look at this one. V 10 meter per second. So that means it is moving. So it has kinetic energy initial. Alright. And then for final position, what kind of energy it has? So it has kinetic energy because it's still moving, but it has no potential energy because it is at ground level. Okay, but you may write U final, and then after that you can substitute it as 0. Okay, plus KF, right? And then write down the formula for potential energy, mg height initial, and then formula for kinetic energy, half kinetic energy initial is half time mass time initial velocity u squared. Okay, and then potential energy final is 0 because at this point, at point A, it is at ground level. Okay, when it is at ground level, it has no potential energy. Okay, and then at point A, it's still moving. Okay, it's moving with velocity at point A. Okay, which is unknown that you have to find. Alright. Again, we can factorize M. Okay, we can factorize M. And then we can cancel the M. We can cancel the M. Okay, both equation, right hand side and left hand side have M. Then we can cancel M and then substitute the value. Okay, G is 9.81. Height initial is 5 meter. Okay, and then half U squared, and it is moving with initial velocity 10 meter per second, and then V or speed at point A is the unknown that you have to find. So VA equals, answer is 14.07 meter per second. Okay, and then VB, okay, speed at point B. Okay, VB. Okay, for question B, you have to calculate speed at point B. Okay, again, you can apply conservation of energy. Total energy initial equals to total energy final. So for initial position, okay, for initial position, you can use this position, okay, this one, or you also can use position A as a initial position. So I want to use point A as initial position. Okay, so I use point A as a initial position. Alright, this is point A and then this is point B. Point A, point B. Okay, this one initial and point B is final now. Alright, so you have to identify what kind of energy at initial position. Okay, so it is moving. Okay, we already calculate speed at point A is 14.07. So that means it has kinetic energy. Okay, and then at point A, it is at ground level. So it has no potential energy. But you may write U initial. But then you can write down, okay, substitute the value is 0. Okay, after this, okay, and then kinetic energy initial at point A equals to total energy final. Okay, where final position is point B. Okay, at point B, okay, you have to identify what kind of energy at point B. So at point B, it has potential energy, okay, and kinetic energy. Okay, it has potential energy because it is at particular height from ground level. It is 3 meter above the ground. Okay, then we can write down the formula. Okay, we can write down the formula. Okay, at point A, potential energy is 0. Kinetic energy is half U squared, where U is speed at point A. Okay, and then equals U final. It is mg h at point B, and then kinetic energy final is half VB squared. Okay, Again, we can factorize m. Okay, we can factorize m. G height at point B plus half VB squared. Alright. So we can cancel m. Okay, we can cancel m. And then we can substitute all the values. VA squared is from question A. It is 14.07. Okay. G is 9.81. Height B. Okay. Height at point B is 3 meter. And then plus half. VB is the unknown that you have to find, squared. Okay, so VB equals, okay, half times 14.07 squared, okay, minus in bracket 9.81 times 3, okay, times 2, then square root answer, it is equals 11.79. Okay, 11.79 meter per second. Okay.